Association Switzerland is thrilled to bring to you one of the Bitcoin pioneers from the very beginning. As early as 2009, he started contributing and researching Bitcoin, which led to a PhD position at the ETH Zurich in 2012 with the Distributed Computing Group, researching the underlying improvements for the consensus mechanism and to enable the network to scale with increasing demand. He then published the very first Bitcoin PhD dissertation, and it's called On the Scalability and Security of Bitcoin. You can read the dissertation and many other publications of his on his website, snicket.net. Tonight, he'll be talking about scaling Bitcoin, and as he is now working on the implementation of the Lightning Protocol with Blockstream. Blockstream is one of the leading blockchain technology providers and is helping to solve the underlying trust issue with the current financial system. So please give a warm round of applause to Christian Decker.
Okay, so yeah, as mentioned, my name is Christian Decker. I'm a Bitcoin enthusiast, and it's been a long journey here. I've always been a techie, and now I'm a software engineer and a researcher at Blockstream. So I'm afraid this talk is going to be a little bit on the tech side. I hope you don't, you like it anyway. Please, if I should lose you at some point, just raise your hand and I'll try to catch you up again. But it should be okay. Okay, so the talk is called Scaling Bitcoin with Lightning. But before we get to Lightning, let's first take a look at what we have so far, what Bitcoin looks like if we want to use it in a day-to-day situation. So the good old on-chain days. This is basically what we talked about during the last 8 years. Is basically what is a blockchain? How can we use it to buy coffee, for example? How can we use it to do day-to-day transactions? Since I see quite a few new faces in the audience, I'll just briefly explain my funny pictures and how you should read them, and also how Bitcoin looks internally. So, if we want to do a Bitcoin transaction, basically, I want to pay somebody with 6 Bitcoins. Let's say this is a colored output called owned by the green user for 6 Bitcoins. Then what I do to give those 6 Bitcoins to the green recipient is I will create a transaction that gives 6 Bitcoins to him. So basically, an output is just a pile of money that is owned by somebody, right? But where do these 6 Bitcoins come from? Well, I got them from somewhere else, right? Initially, I had like 9 Bitcoins lying around somewhere, me being the blue guy in this case, and I use a transaction to redistribute this value to new owners. 6 being the intended action that I want, namely transfer 6 Bitcoins to somebody, and 2 Bitcoins go back to me. Now, the eagle eyes among you might have noticed something weird in this case. Okay. So if we look at what we had initially was basically we had 9 Bitcoins, and what comes out at the end is 8. And the difference in here is what's usually called a fee. So that's a fee I pay to the network to process my transaction. And the rest of my talk, I will disregard fees completely, but always keep in mind we have to take care of them. Disregarding them just makes my numbers a bit nicer to look at. Okay, so how did we get these 9 Bitcoins to begin with? Well, we got them from a prior transaction. So basically, the inputs to one transaction are the outputs of the next transaction, of the prior transaction. And so we chain transactions, splitting and redistributing funds over and over again. Now, one interesting detail that not many people might be aware of is that how do I set up the spending condition, namely who is allowed to redistribute these funds? Well, we do that by having what's called a script pub key. This script, which I represent as this small square there, is basically just, in order to spend these funds, the spender must provide something that satisfies this condition. How do I provide that? Well, we use a script sig or an input script which provides the data necessary for the output script. And if that whole thing returns true, then indeed I just authorize this transaction. And of course, the same is true for the other side. So now that we have these funny pictures, let's look at how a usual flow works in Bitcoin. So assume I want to buy coffee. I'm the guy on the left side, and my coffee is far over here on the right side. I quite like my coffee, so much that I've often been called a coffee compiler. So what I do when I want to pay with Bitcoin, as we're used to, I basically create a transaction. In this case, I take 5 Bitcoins from somewhere. I want to transfer 1 Bitcoin to the barista, and I transfer 4 Bitcoins back to me. I then send this transaction to the Bitcoin network. In the Bitcoin network, each individual node will receive this transaction, verify, OK, this guy is actually authorized to spend these funds. Yes, those funds haven't been spent so far, and I can actually apply this to my local ledger. And once they verify this, they will forward this to the other participants in the network until eventually everybody knows about this. And we should be done, right? We all agree that these funds just were transferred. Well, it turns out that the consensus mechanism in Bitcoin tells you to now wait for 10 minutes. And it's always 10 minutes an expectation. Even if I waited like 20 minutes so far, an expectation I will wait another 10 minutes for the confirmation. Eventually, a block will be found in a network. My transaction will be confirmed, which I usually represent with a lock on the transaction itself. And I can finally get my coffee. Now, this is a rather tedious process. It's slow. And by the time I actually get my coffee, it's cold. And I really hate cold coffee. Well, except cold brew, which is OK. And the fun part is that this is a really mundane task. I was just on a hack day during the last weekend where people actually complained to me about having to wait 100 milliseconds for a payment to go through. So having to wait 10 minutes here, which might be OK, is definitely not OK for people that want to create a website, an interactive website that has a payment associated with it, and they have to react in less than 100 milliseconds. OK. But how can we actually perform payments in less than 100 milliseconds? Well, that's what I'm here to tell you about, which it's Lightning. OK. Lightning is basically one instance of an off-chain protocol. An off-chain protocol basically is just a mechanism in which we can lift some business logic from a blockchain, iterate quickly among ourselves, and then reflect these changes back to the blockchain itself. So how do off-chain protocols work? Well, off-chain protocols usually work in this fashion. So assume we have a set of participants on the left side, and we have this, which is basically the materialized ledger at some point in time. So this basically means that Alice has 5 Bitcoins, Bob has 5 Bitcoins, and Carol has also 5 Bitcoins. Now assume that on the left side, those are Alice and Bob. They now want to initiate an off-chain contract. They want to speed up their interactions. What they do is basically they lock part of the ledger by transferring their funds into what's called a multisig address. A multisig address basically means that both of them have to provide a signature or sign off on anything that happens to those funds. What we do then is basically we take that state, lift that partial state off the blockchain, and represent it here as a smart contract, an off-chain contract. Initially, this off-chain contract basically reflects what we had before. Alice owns 5 Bitcoins, and Bob owns 5 Bitcoins. And now we can start discussing how do we actually split this ownership. So at some point, Alice might give 1 Bitcoin to Bob, now adjusting the balances. And then we might give a lot more to Bob, and we might give some back to Alice. notice that all of these states, all of these intermediate states are basically represented as Bitcoin transactions that we don't send to the Bitcoin network, we keep in our back pocket. And eventually, once we're done doing our off-chain discussion, we can take the latest state of this off-chain protocol and apply it to the global ledger, and then we basically just settled our off-chain contract by applying the aggregate of all of the intermediate interactions onto the Bitcoin blockchain. So that's the abstract way this whole thing works. Obviously, this is very simple, very much simplified. But does anybody see an issue with this? So we have an initial state, we just incrementally changed over and over again, and all of these intermediate changes are represented as transactions. These transactions are valid. Is there an issue here?
No fees.
No fees, for example. Yeah, that's a good one. We'll have to come around to that one. Yes.
You could send an old transaction to the network.
Yes, exactly. So the point is that we actually could send an old version to the network. So basically, we just agreed that Alice owns 6 and Bob owns 4, right? But what prevents us from actually using this, which gives Bob like 1 Bitcoin more, or even worse, this, which gives him almost the entirety of this thing? So you see, at some point, we actually need to invalidate old states, right? And this is the core problem we have to solve in all of these off-chain contracts. How do we invalidate? How do we update without the old state being applicable to the network anymore? And that's basically what we do with Lightning. But before we talk about Lightning and how it works, let's quickly see why we want that. So Lightning is often mentioned in the context of scalability. Scalability obviously is the big one. We had like 2 years of very heated discussions about this. Some people went different routes. Some people basically reinvented the wheel. But I also put under scalability that we have true real-time payments. Since we now have an off-chain contract, we can actually negotiate updates to this off-chain contract at the same speed that we can communicate. There is no longer the need to reflect every single change onto the Bitcoin blockchain. Yes, there was a question there?
When you say true real-time, I mean, there is some time needed to set up first the off-chain.
Yes. So the comment is that we need some time to set this up, right? That's true, but once we have this set up, it is real-time because we can actually update this in the same, at the same speed we can communicate.
So if you take your example of the coffee, so
yes.
When I'm visiting a city, I'm not visiting, and I want to buy a coffee where I just do it just once in my life, how much time would I need to spend before I get my coffee?
Yes, so the question is basically how much time do I need to set up one of these channels? If you just look at one channel, it's true. I would need to set up a new channel to the barista every time I change barista or I visit a new home. But there's a second part of the name Lightning Network, which indicates that we have a network of these channels. And so we can do multi-hop routing from any point to any other point in the network at sort of the same speeds without needing to set up a new channel for each individual recipient. I'll not talk about too much about this, but we have a mechanism in which we can actually have a similar setup like the internet, where if you're talking to Google, you're not actually drawing a new connection to Google just to talk to, or you're not wiring up your computer directly to a Google server, but you're going through maybe Cablecom and then Sunrise and then some 3G network. So having this multi-hop mechanism actually gives you a lot of connectivity there. Okay, we have immediate settlement. As I said, my coffee's getting cold. I'd like to have confirmation that the payment actually went through before it gets cold. And we also have a huge privacy improvement by simply not having every single one of our transactions be reflected in an immutable state, in an immutable store, which is basically a blockchain, right? If I can aggregate individual transactions into bigger transactions, and if I can mix in transactions from other people, I can hide basically my activity that I'm doing in the network, and the state that is in a blockchain becomes far less useful to create profiles about my usage. Now, that might not be what big companies want from this, but I, as a user, I'm really happy that I can't be profiled that well. And finally, we also have true permissionless innovation. One of the big downsides of having a blockchain is that we all have to not only agree on what happens on the blockchain, but we also have to agree on the rules that we apply to what is valid on the blockchain. So if I want to change those rules, that's a really involved process. And that's what we've been noticing in Bitcoin is basically that, yes, changing rules is really, really hard. And it should be hard, because this is a global consensus that people rely on being correct. Okay. So let's come back to update mechanisms. As I said, the core principle, the core difficulty in all of these off-chain protocols is basically that we need to have a way to update our state and invalidate the prior state in such a way that only the latest state can actually be applied. And I'll go quickly through 3 different architectures of this, and in increasing, it's not increasing amount of complexity, but the first one is rather simple. Okay, so the first one is called simple micropayment channels. We knew about this back in 2011 even. It was invented by Spielmann et al. And it allowed us to have really quick updates and incremental payments for stuff. And it basically worked like this. So we have, initially we have some funds owned by somebody, let's say the sender of the sender of this payment channel, as we will call it. He will create a transaction that has one output. This one output has 5 Bitcoins in it, and this 2-colored thing basically means that in order to spend from it, both the green and the blue party need to sign off on whatever happens there. Okay. So once we have that, we can then go ahead and have our state. As I said, our state will always be represented as a Bitcoin transaction that reassigns value from one party to the other. So the initial state, obviously, since green funded the entirety of the channel, is that green will get back the entirety of the channel and blue will get nothing. In reality, the blue one will be cut off, but let's leave it like this. So at this point, the green node will provide his signature to this transaction and send it to the blue participant. Now, the blue participant has 2 choices, right? The blue participant can now add his own signature, completing this transaction, making it complete, and broadcasting it into the network. Or he can say, I don't get anything from this. Maybe the green one will come back and give me some more, and puts it in his back pocket. Now, the green participant can go ahead and send the transaction into the Bitcoin blockchain, and we confirm it. This is basically the setup of our channel. Okay. Now, assume that blue is my barista, and I actually want to buy a coffee. So I, being the green one, go to the barista and hand him a new transaction, spending the same funds that I set aside, and giving 1 Bitcoin to him and 5 back to me. So I just did an incremental payment to the barista for the amount. I signed it, and I will send it over to the barista. Now the barista says, hey, I have these 2 transactions. One of them gives me nothing. The other one gives me 1 Bitcoin. I'll throw away the old one. I'll keep this one Bitcoin transaction. I'll put it in my back pocket. He might come back for more coffee. And indeed, I will come back a few more times. As you can see, I like my coffee. Until eventually, I have spent the entirety of the funds I had in this channel or I move places and I don't want to pay him anymore. So at that point, the blue participant will basically add his signature, completing the transaction, send it into the Bitcoin network, and eventually this whole thing will settle, will be confirmed. And what we've just done is basically have four off-chain transactions, and our on-chain footprint is comprised by those 2 transactions. Nobody will be any wiser about what happened in between the setup and the settlement transaction. All they will see is that a total of 4 Bitcoins have changed hands. And if we're clever about it, they won't even learn that. It might be 1, or it might be 4, or we might do some other construction. So this is a very simple one. Any ideas why it's called a simple micropayment channel and we can't use that all the time?
Just one way?
It's just one way, exactly. So in this whole process, the only thing that prevented an old state from ending up on the blockchain is basically the greed of the blue participant, right? The blue participant is incentivized to only always use the latest state. So if we were to, because that's the state that gives him the most money. So if we were to basically go back from this state to this state, where the blue participant had 1 Bitcoin less than before, do you think he would throw away the old state and keep the one that and sign it the one that gave him less, or would he use the one that gave him more? Obviously, he would take the one that gave him more. So we can't move funds back from in the other direction. And indeed, there's quite a lot of work to be done before we can actually do a bidirectional channel. But that's exactly what the Lightning paper managed in 2014, I guess. The Lightning mechanism, I'll call it Lightning penalty, although some people don't like that name, is much more involved, but it actually allows you to send money back and forth multiple times. And if you think about it, sending money back and forth multiple times is what actually gives this value. I can put 100 francs on the table, and if I have a unidirectional channel, the entirety of the funds that I can transfer is 100 francs. Now, if I put 100 francs on the table and I can send it back and forth multiple times, I have infinite. I get the utility that from the transfer of being able to transfer it multiple times back and forth. So this is a multiplier of the utility I get there. Okay, so this mechanism is the most hardcore, and it's also the one that I always struggle to explain. So bear with me. So we divide the plane into 2 parts. The upper part is what the green node knows about. The lower part is what the blue node knows about. And what we have now, what we have is the usual setup transaction where we have 5 Bitcoins. We create the multi-sig account and we confirm it. Now, the first state we do is we create this state twice. We have the blue node has this transaction and the green node has that transaction. Both have the same sort of effect, right? From those 5 Bitcoins, the green one gets 4 and the blue one gets 1. Now, we want to update this and transfer 2 Bitcoins from the green node to the blue node. Again, we create one set of transactions. Each one of the participants has one of those transactions. And we're back at the usual problem. How do we now invalidate this part of our construction? This is where the green node might be incentivized to use this old state because, well, it gives him more money. The way we do this in Lightning is basically through a penalty. What we do is we have this transaction gets poisoned, and we have a certain time period in which this 1 Bitcoin here can belong to either the green or the blue node. And if we want to invalidate that state, now I need to look at this. The blue node hands the green node a transaction with which it can punish him. and the green node hands the blue node a transaction with which he can punish him. So basically, if I'm trying to cheat and I'm the blue guy, I will publish this transaction. But the green node already has a tailor-made reaction which steals all the money that I would get out of this. He steals it for himself. So I'm highly disincentivized to ever look at this again, and indeed we will just drop that on the floor and never look at it again. Okay. And indeed, we can do that a number more times, basically transferring back and forth, poisoning the old state, and then only keeping the new state around. And that goes on forever, and we can actually do that any number of times before we need to settle. Now, this is a rather complex thing, and we always need to carry these guys around and watch out for any of these transactions to go on chain, because our counterparty might actually cheat. So what I did was basically come up with a new mechanism that is a bit simpler, and that's what I call L2. In L2, basically, we have the usual setup transaction, and we have the usual multi-sig account. And the first thing that we do is basically we create a settlement transaction that reflects our desired state. Now, notice this timeout here. So once this transaction is created, we have a certain timeout before this transaction becomes valid. Now, we have this timeout in which we can actually go and negotiate a new state. So let's say we negotiate update 1, and this new state in which I have 4 and 1. Now, as I mentioned before, if I have a 10 franc bill or a 5 franc coin on the table, I can only spend it once. Basically, by attaching this update transaction, I've just invalidated this whole subtree here. And so we've just created the update. This timeout starts to tick. We have this settlement that will eventually become valid. And we now have time again to basically renegotiate and create update 2, settlement 2, and so on and so forth. And it's far fewer transactions that actually need to go, that we need to keep around. And we can actually guarantee that none of these will ever end up in the blockchain. So there's a really silly mistake in all of this, and I'd like somebody to point it out now. Is there somebody who can? So I mentioned that this is a scalability solution, but what we're actually doing is creating this huge chain of updates. Every time that we change our state, we now add a new step and add a new step and add a new step. And to get to this settlement 3 here, I would have to publish this setup transaction, update 1, update 2, update 3, and now settlement 3. Well, that's not really good, is it? How would it be if we could short-circuit this? How would it be if we could, say, attach update 3 directly to our update and skip all of the intermediate ones? And we have a proposal pending that basically allows us to do this in Bitcoin, and the changes are rather minimal. So I wanted to quickly go through the mechanism, through the different scenarios here, and just show you how this would work. So we have the setup again, and at some point we decide we have done some updates, and at some point we decide, okay, let's close this. I'm done. I don't want to talk to you again. So what we could do is basically just wait out this timeout. What we could also do is just create a collaborative close, basically meaning we create a new transaction that takes these funds and splits them up just like we decided to, without timeout, without anything. That's what's called a collaborative close. In the case that one of us becomes unresponsive, his computer burned down, he's just a really unlucky guy and his phone dropped into the ocean, which happened to me 2 weeks ago, we can also just take the last update, attach it to the setup transaction, and confirm it, but at that point in time, we actually need to wait for this timeout to drop. Or I could be a very bad person and try to actually, you know what, this transaction gave me more money. I want this to be to confirm. I actually want to cheat you out of your money. So what I do is basically I publish update 1, and now I have to wait for 24 hours, for example. And in these 24 hours, you can come along and say, no, 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 no. You're not stealing my money. I'll take the later state, attach it to update 1, and override your desired effect. Basically, I just spent a lot of fees to get update 1 into the blockchain, and you still get your desired outcome of having state 3 go through. Okay, that's the tech part of all of this. I hope it wasn't too confusing. Yes? Yes. Yeah.
Still, that guy playing update 1 and then going with settlement 1, would be the lucky guy which has tricked the system.
Yes. Okay. So the question is basically, if I were to lose my phone and my counterparty would be able to identify that I lost my phone and basically be able to tell that I won't be able to react in time, then he could cheat me out of my money. That's true. But in the case of a phone, I would just insist on having a longer timeout. So we can basically change those timeouts in there to be whatever we are comfortable with. So if I'm running the software on a phone, then I'd probably not be happy with a 10-minute timeout. I would also not be happy with a 1-day timeout. I would probably go for 2 weeks. 2 weeks to restore a backup and close my channels should be doable. But we can basically tweak those trade-offs however we want. Yeah.
Two parties who can decide what's long enough.
Yeah. So who decides what time to take? We'll basically take the maximum of the two approaches. So I'll say 2 weeks. You'll be saying 1 day. And either you accept that we agree on 2 weeks, or we don't open a channel at all. Basically, I, being the more cautious guy, will override your decision. And if you're not happy with locking in your funds that long, then we don't have an agreement, and I'll just look for somebody else to connect to. Cool? Okay. So this is an update mechanism in Lightning, and as I mentioned before, this is small part of the entire Lightning stack. I have just a really short picture of how the actual stack looks like, and as you can see, this is the small part we've just spent half an hour talking about, and we have transport encryption, we have a base negotiation feature, we actually have a transfer and a multi-hop feature that allows us to have this networking aspect of the Lightning network, namely that I can open a channel to any one of you, and as long as we have some connectivity through that graph, I can still send money to any of you. We have a onion routing protocol as well, so even though I will be sending my transfers over multiple participants in this room, all you will basically see is that you get a payment from left, you get instructions with that payment, and you will forward it to right. All you will really learn about is, okay, I got a payment from this guy, but you will not learn about who came before him, and you will forward it, but also not know who came after that, and you'll also not know your position in this whole route. So we end up with a situation where you are forwarding payments and being paid for it, but all you learn really is your direct predecessor or your successor. Okay, so usually at this point I get the question, when moon? Which is basically a euphemism for, okay, when will all of this take off? And when do we actually get to play with this? And the answer to this is, well, right now. This is a picture of the Lightning Network I took this morning. Points are basically nodes running in the Bitcoin network, and edges are channels that are open between them. And so if I were to transfer from this node to one of the nodes in San Francisco, I could basically take this channel here, hop through Florida, and then over to San Francisco. So this network is very active at the moment. It's still a bit hard to get started, and I wouldn't encourage to try running it if you're not, if you don't like crashes and you don't like frustration. But we really want to encourage people to start playing with it, sort of dipping your toe into the waters and see what temperature it is. We currently have like almost 2,500 nodes running online. We have 13.2 thousand channels open, and we have over 100 Bitcoins committed to the network. So that's $700,000 of people brave enough or reckless enough to play with this stuff right now. The other stats I would like to give you are basically how many transactions can we do? And how many fees are we paying for those? And the answer is, well, we don't know. Because this is a very high privacy network, and we don't actually know where funds are being moved around, how many fees are being gathered. It could be zero, it could be millions. We just don't know. And that's a feature in this case. So I hope you will eventually try it. We're looking for feedback on what we could improve and how we could make it more user-friendly. Or if there's something that you'd like to see in all of this, please tell us. We have 3 main implementations, and 2 more are just getting started and implementing the specification. This is an open source effort. We're developing the specification in the open, so everybody's free to come and help us or bring their own ideas into the project. And we'd like to see all of you use Lightning eventually. So that's it from my side. I hope I could give you a quick glimpse into the technology. And are there any questions?
Yeah. Thank you for your talk. And just a question. As I understand that I would have to have a node in my phone to use the Lightning Network. Would it be like possible to have like a node on my home computer and my phone communicates with the computer at home? So when I lose my phone, there's actually no harm to my funds in the Lightning Network?
Yes, absolutely. So there's different models that we try to look at these. Some are running the entirety of the software on your phone with all of the risks and upsides that you just mentioned. But there's other mechanisms we look at. I'd like to have just a simple plug that I could plug into in at home and then touch with my phone so I can pair it. And then whenever I'm outside, I will actually talk to my home hub, so to speak. And that will take care of connectivity, of sending out a penalty if somebody tries to cheat me, or just provide the stability and backups that I like to have, while still keeping all of the upsides of having a mobile device with you. So that's one side. Or we actually do have several wallets that will do that right now, but they are still a bit clunky from time to time. But we're working on different solutions. And just like nowadays, not everybody is running around with a hardware security module in their pocket and tapping it on point of sales or scanning QR codes. There's different ways this will turn out to be used, probably, hopefully.
Hi, thanks for the talk here.
Oh, yeah,
here.
yeah.
Yeah. I saw that Sphinx is mentioned on your layers for the multi-hop.
Yes.
Can you talk a bit more about what is Sphinx and how it works?
Yes. So Sphinx is basically the onion routing layer, which basically means that whenever I initiate a payment, I will have this encrypted piece of data that is transferred along with the payment. And every single participant or every single hop in my path will be able to decrypt part of it, what's called an onion decryption. And that part of it will basically tell it, okay, you just received X from the predecessor. Please forward X minus fee to this peer you have. And then he will also add this encrypted piece of data with the forwarding, and then the next one will also be able to say, okay, I just got that, and here's the information I need to forward it. And in the end, eventually somebody will be the final recipient and say, see, okay, I just received this money, I'm supposed to keep it, I'm happy. So basically, the Onion, the Sphinx protocol is an implementation of the Onion routing protocol, which allows us to give instructions to nodes without telling them the entire information about where this money came from and where it's going. Unlike IP, where you basically have, okay, this is the address of the sender and this is the address of the recipient, and every hop in between knows exactly, okay, this came from America and is going to Iceland, basically. Yep.
So, first of all, thank you for the presentation, which was very understandable, which is not given.
Thanks.
Always in this space. My question is, if I run a node, is there any legal concern or something if, given that I'm transferring money through my channel?
I'm by no means a legal expert.
Okay.
But it's hard to imagine that. So it's hard to sort of follow the money. And I will always have plausible deniability that I didn't know who was the destination or who was the sender for this money. So hopefully we can eventually make the point that just transferring money should not put me in hot water. But again, I'm not a legal expert, so don't hold me on that one. Yep.
So Lightning's going to work on Bitcoin?
It is working on Bitcoin.
Okay, so it's working on Bitcoin.
It's working on Litecoin, and we have a few other coins that are trying to migrate it to there.
So will it work on things like Zcash and other Bitcoin derivatives, or is that up to that team to actually get Lightning to work?
I'm not sure about Zcash. There might be some issue there that I'm not aware of, but it should definitely work with currencies that sort of that definitely the ones that forked off of Bitcoin. Those should work. It will not work on Bitcoin Cash though, because you need a malleability fix, which they apparently don't want. So most of the coins that use what's called the UTXO model will be able to make use of this in one form or the other. And who knows, maybe we can get fixes for Bitcoin Cash as well, at which point they will have that as well.
Hi there. One of my questions is the risk of centralization. So let's say you have wallets and one wallet becomes really popular because it has 100 developers and a corporate team and it's the most popular, and they have one node which does half of the transactions on the Lightning network. And then this node goes down and the timeout is 2 weeks or something and the network is cut off for a very long time. Are there risks of centralization? And if so, what are the best ways to combat them in your opinion?
So you just mentioned one of the principal drivers against centralization, namely that having a network that centralizes around a few nodes a few popular nodes, suddenly becomes a single point of failure. So simply you being rational and wanting to defend against the single point of failure should be enough for you to create diversity in the network. On the other hand, it's rather expensive to run one of these big hubs. You have to commit a lot of funds to them, you have to keep it running, and the fees you will be gaining are not that big. I mean, if you were to charge a big fee, then you would basically be creating an incentive for other people to create alternative routes around you, basically fee dumping you. So what we'd actually like to encourage is an as homogeneous network as we can get, with nodes that sort of build bridges and not just look for the shortest path. And it also gives you a lot of advantages from a privacy point of view. If you have one node that acts as a hub for everybody else, and it gets a payment from one node he knows is a leaf of his, then that node basically knows that the origin of that payment is that guy, right? And if he forwards it to somebody else who is also a leaf in this graph, then he knows that that is the intended recipient. So hopefully the low fees, the high cost, the privacy implications, and the stability implications should be enough to sort of get us to a network that is not as centralized as some people might fear.
Christian,
yeah.
I am running one of these nodes because I wanted to buy a T-shirt in your store.
Yeah.
And so I noticed when I open a channel, I commit some Bitcoin, but then I cannot increase the capacity. Am I doing something wrong, or how does this work?
No, indeed, oh, did I not disable my screensaver? So indeed, at the time you open the channel, you're committing the funds that are the maximum of the funds that you will ever have on that channel. That's simply because, well, because adding funds to a channel basically is an on-chain operation, which is costly. But we have mechanisms that we are planning for version 1.1 of the specification called splicing, which will allow you to temporarily disable the channel, basically settling it, adding funds in, and then restarting from this new output, starting a new channel. And the ultimate goal is basically that we will have everybody can have all of their money in channels and also be able to do what's called a splice out, basically do an on-chain payment from a Lightning channel. Basically, temporarily closing that channel. With the closed transaction, we split off some funds and then we reopen the channel again. And that way, you don't have to actually care anymore, oh, do I have 10 Bitcoins on-chain or 5 Bitcoins off-chain, but I want to pay 13, so what do I do now? You can actually combine those and have off-chain, seamless on- and off-chain payments from the same amount of funds. So yeah, it's still an issue today. Hopefully we can fix that in the next iteration. We just wanted to push this 1.0 version out as quickly as possible so that we can actually get user feedback and get started with this all.
Great. Thank you so much, Christian, for this enlightening talk, to use the pun. Thank you.